So we have one more problem for this chapter end. So there is a load of 30 pounds. The question is that what is the angular acceleration? So we assume it is a uniform cylinder and there is no slip. Okay, so first let's start with the force balance. We have this load with a horizontal component of P of x and vertical component of P of y. The angle here is 30 degrees. This is the load. And then P of x is P cosine 30 and cosine 30 is 0.866. And P of y is P sine 30 and then sine 30 is 1/2. And then we have the weight. We have a normal force and then we have the frictional force. The frictional force, so to find the direction of it, it is a little bit, it looks like it's the most important part of the problem is to find the direction of the frictional force. It is not always intuitive. Okay, so think of this way. When you push this one, the wheel, so say that there is no rotation. Okay, this is the assume. Because with the rotation, to understand the direction of frictional force is tough. Without the rotation, when you apply the force, but let me add this one as well. There is rotation, there is not rotation. It doesn't change the nature of the frictional force. The frictional force is always reactive, independent of its type, whether static, dynamic, rolling friction, whatever. So that's the reason that you can ignore the rolling effect and just look for sliding. Okay, this one is assumed there is no rotation. Okay, and then we assume that it slides. And when you push it, when it slides that way, so it slides. You push and it slides, and then frictional force must be this way. Okay. And then same applies for the rotation as well. When you push, the ground pushes this way, and that causes the rotation of the wheel. Or you can assume there is no friction. If there is no friction, it will stay as it is. It will not rotate. It will not move. Sorry. Anyway, so the first case without rotation, if you assume, you will get the correct answer. So that will be the f of f. Okay, and then now the time is to write the force balance. We have f of x, that is, let me put this in the next slide. F of x will be magx, and then we have negative f of f, then we have p of x, magx. This is the first. Second is that f of y is mfgy, and there is no acceleration in y direction, so we have the negative p of y. Let me put directions as well. This is x and that's y. Negative p of y minus w plus n, that's 0. That's the second equation. For the first equation, you can see that we have the unknown of f of f. It is unknown. So we have one equation, two unknowns. Here we have one equation, one unknown. Okay, then the third one is that we will use the moment diagrams, moments about g, that will be I g into alpha. Okay, so alpha is, this is the direction of alpha, clockwise, and then therefore it is negative. Let's write the forces. G, N, P doesn't create any moment. So P, G, and then L all pass through G. Okay, no moment. Only we have a moment with respect to f of f with an arm of 1.5 feet. So f of f times 1.5 feet, and this one is a clockwise moment. That's negative. That is ig into alpha is also clockwise. That will be negative ig into alpha. Okay, so we have here one unknown and then one equation. We have 1, 2, 3 equations, 2, 1, and then 1, 4 unknowns. We need one more equation. One more equation. And that equation will come from the kinematics of the problem. We know that ag of x is alpha into r. Okay, that is by the kinematics of the problem, because this one is no slip. That's the reason that we can use this relationship. And then for this one, we have to find the direction of alpha and then x. The alpha is clockwise. Okay, so let's use this one. Alpha is that way, clockwise. And this clockwise can create an acceleration this way. Okay, acceleration this way. That's the reason that it is a positive quantity. Agx is positive alpha r. Okay, or you can use alpha cross r. You can use this relationship as well. Anyway, this is the fourth equation, and then with this fourth equation we have 4 equations and then 4 unknowns. Okay, so we can solve the problem one by one. So let's start with the second equation, which looks easier. Negative p of y, we said that it is p by 2, that's 30 by 2, which is 15, negative 15. W is given as 50 lb, and then n is unknown, that will be 0. Then from here n is 65 lb. Okay, so we have found the n value. Now the time is to find the, let's go back to this equation. So we have f of f plus pfx into 0.866, it will be 0.866 times 30, that will be 25.98, that will be 26. That will be m. Instead of agx, I will just put as, instead of m, let's write 50 by 32.2, and then instead of agx, I will just put alpha, and instead of the r radius, which is 1.5, 3 by 2. Okay, this is the, then f of f plus 26, that will be 50 by 32.2 times 1.5, that's 2.3 alpha. Okay, that is this equation. Okay, then the final equation will be the moment diagram, and for this one we need the value of ig. Then ig for a cylinder, so it says that it is a uniform cylinder. Let's see what we have here. So for a uniform cylinder, so this is the equation that we have. And then we are looking for the rotation about the z-axis. Okay, this is what the question says. The rotation, it rotates about the z-axis, the axis passing through the center of it. So for that axis, we need 1/2 mr squared. But even if you use the thin circular disc, you will get the similar, exactly the same answer. 1/2 mr squared, that will be ig. That will be 1/2, m is 50 by 32.2, the r value is 3.2, then squared That will be 50 by 32.2 times 9 by 4 and then by 2. That's 1.75 slugs and then feet squared. Okay, so in the next recording we will continue from here.